Hello, and welcome back to the video for lesson 1.4. This lesson is all about experimental design and ethics. So far in the earlier lessons of chapter 1, we've talked about who or what we want to learn about, how we're going to gather data on those people or objects, and what types of data we're working with. And now we're going to talk about the actual study of how we're going to get that data and how we are actually able to use the data that we have. So there are two types of studies. One is called an observational study and one is called a designed experiment. An observational study measures the value of the response variable without attempting to influence the value of either the response variable or the explanatory variable. So let's just go down for a minute and go over those two. Explanatory variable is here. The explanatory variable in, if we go back to algebra, would be what we would call the independent variable. Okay. The response variable is the affected variable. So this is in algebra what we would call the dependent variable. So the independent variable may have some causal, and I'm loosely using the word causal relationship to the dependent variable. Okay. So that is in an observational study, the researcher observes the behavior of individuals without trying to influence the outcome of the study. Observes. Okay, that's the key there. In a designed experiment, it's a controlled study to determine the effect of varying one or more explanatory variables or factors it has on a response variable. Any combinations of the values of the factors is called a treatment. So a designed experiment is where we randomly, that's the key, randomly assign subjects to a treatment group. Okay, so for instance, if I said that smoking causes cancer, and I know this because I had a group of people smoke for 10 years, and then I looked at the percentage of those people that had cancer, and then I had a group of 50 other people that I saw that they didn't smoke for 20 years, and I took their percentage of those people that had cancer. That's an observational study. I didn't randomly put them into groups and then measure who had cancer and who did not. And when I randomly assigned them into groups, I did not say you have to smoke for 10 years or 20 years, and over here you cannot smoke for 20 years. That's not something I can do. Okay. I couldn't ethically tell somebody that, oh, you have to be in the group that has to smoke. So we have to be careful about what, when we read things from in society anywhere, could they ethically, or could they really put this into a design experiment? Could they randomly assign subjects to a treatment group? Okay. So an experimental unit is a single object or individual to be measured. So that could be a person in a study, in a medical study. It could be a car in a study. It could be a computer chip if we're trying to test different computer chips. So it's whatever you're studying. Okay. A confounding variable. So a confounding variable is one that influences the dependent variable outcome, but was not separated from the independent variable. So if we go back to my little example about smoking and causing cancer, it might also be a confounding variable, and that could be somebody that drinks, because people that smoke often also maybe abuse alcohol. But I wasn't actually measuring or testing for alcohol. I was only just looking to see if there was a relationship between somebody that smoked and the outcome of cancer. So that could be a confounding variable. Additional variables that can cloud a study are called lurking variables. So lurking variables are variables that we don't know about that could be out there affecting our dependent variable as well. Additional variables that can cloud a study are called lurking variables to the placebo. So a placebo is a neutral treatment that has no effect on the response variables. Sometimes we give that so that we have kind of a control group. And a control group is a group that receives a baseline treatment that can be used to compare to other treatments. So we might give the control group a placebo. It would be like a fake treatment. You might also say fake treatment. So control groups can be established in a wide variety of ways, such as no treatment, neutral treatment, placebo, standard treatment, etc. Control group means the group that receives the baseline treatment, not that the group is controlled by the researcher. So they just get like a basic. So sometimes in medical studies, they will give a sugar pill. So the experimental unit, so the human, right, the individual might think that they're getting a treatment, but they're really not getting a treatment. They're just getting a sugar pill. And that's called blinding. The blinding in a randomized experiment preserves the power of suggestion. So when a person involved in a research study is blinded, he does not know who is receiving the active treatment and who is receiving the placebo. And they do that because sometimes, like if it's something, let's say I worked on a study for migraine treatments, and some of the symptoms of a migraine are how they feel, right? They might feel dizzy, or they might like feel like they can't open their eyes because when they open them, it causes them to feel dizzy and want to be sick, or hearing sounds bother them. So if I am having a study where people are taking a drug for migraines and they come into my office and I ask them, oh, how do you think the medicine is helping you? They may automatically think, oh, I'm feeling better because I'm getting the treatment drug, but they might be getting just one of the placebos. They might be getting like a sugar pill. And so they might think, oh, just because they're getting the medicine, they're feeling better. But if they're blinded, they don't know if they're receiving the drug or not. So that's a good thing to do blinding. A researcher can also do a double-blind experiment. It's in one in which the subject and the researcher does not know that they're blinded. A case for this might be also in a medical situation where the researcher is observing a patient. So for instance, if a patient is maybe an MS, multiple sclerosis patient, they tend to have symptoms of being very dizzy and wobbly and not being able to walk straight. And so that means they'll come into the office and the researcher will observe them and have them walk in a straight line and decide if, measure how they're walking, how their gait is what it's called, if their gait is straight. And if the researcher wants to show that their drug is doing really well, they may go, oh, these people are taking the drug, so I could tell their gait, their walk is much straighter than those that aren't taking the drug. So it's better if you do a double-blind experiment where the researcher does not know who's getting the drug and who's not, because when they go to make those observations in their office, they won't already have a preconceived idea of who might be doing better. Okay. So the only way that we can say that the explanatory variable causes the response variable is if you have a designed experiment. If it is an observational study, you cannot say that. So that's where you might have heard the term correlation does not mean causation. And that is true. We might see some correlation. We might see some relationship in our data between the explanatory variable and the response variable, but it does not mean causation unless you have performed a designed experiment. Let's look at a few examples. So example 1, it says a researcher wants to study the effects of birth order on personality. Explain why the study could not be conducted as a randomized experiment. What is the main problem in a study that cannot be designed as a randomized experiment? So we cannot choose a person's birth order. So that means we cannot actually do a randomized experiment here. And so it says, what is the main problem in a study that cannot be designed as a randomized experiment? We cannot say there is a causal relationship. Remember, there might be some kind of a relationship, but we can't say it's causal because correlation does not mean causation. Okay, example 2. 2 groups of college students are randomly selected. One group is shown a promotional video on purchasing life insurance after they graduate. The other group is not shown this video. After this, each group is asked if they are planning to purchase life insurance after they graduate. Is this an observational or experimental study? This is an experimental study. They are randomly selected, and one of them is getting a treatment and one of them is not. Okay, randomly selected. One group is getting the treatment, which is watching the video, and one isn't. Make sure it's zoomed in for you. 2 groups are randomly selected. Example 3. One group receives a lecture on the importance of mathematics in their lives. The other does not receive a lecture. Afterward, both groups complete a questionnaire on their attitude towards taking a mathematics course in college, and the results are compared. Is this an observational study or experimental? Again, this is an experimental study. They were randomly selected. One group watched the video or had a lecture on how mathematics is so great in their lives, and the other group did not. So when we're talking about studies, observational and designed, we have to talk about ethics. And I've already mentioned ethics a little bit when I said we could not ethically make a group of people smoke cigarettes for 10 or 20 years. So the widespread misuse and misrepresentation of statistical information often gives the field a bad name. Some say that numbers don't lie, but the people who use numbers to support their claims often do. So it is important to be cautious about where the data is coming from. When we hear data in the media, when we read data in news articles, when we read data on products that we are going to buy, right? That clinically proven, we see it all the time. Or data from, automotive makers, and especially pharmaceuticals are a big one. People trying to sell you things that are going to help you lose weight without doing anything with your diet. People that are going to take away all your wrinkles, things like that. So it's important that we actually are critical thinkers about that. So let's look at example 4. It says, describe the unethical behavior in each example and describe how it could impact the reliability of the resulting data. Explain how the problem should be corrected. So A says, a researcher is collecting data in community. She selects a block where she is comfortable walking because she knows many of the people living on the street. If we look down at the solution here, it says by selecting a convenient sample, notice it was a convenient sample, the researcher is intentionally selecting a sample that could be biased. Claiming that this sample represents the community is misleading. The researcher needs to select areas in the community at random. So she's only choosing people that she's familiar with in an area that she feels comfortable being in. So that's A. Let's look at B. B says, no one seems to be home at 4 houses on her route. She does not record the addresses and does not return at a later time to try to find residents at home. This is not good because she is omitting people just because they weren't home. And so she's not really capturing everyone that she should be in her sample. It says, suppose the researcher is gathering information about jobs and childcare. By ignoring people who are not home, she may be missing data from working families that are relevant to her study. She needs to make every effort to interview all members of the target sample. Let's look at C. C, she skips 4 houses on her route because she is running late for an appointment. When she gets home, she fills in the forms by selecting random answers from other residents in the neighborhood. Oh no. So here she's falsifying data. It is never acceptable to fake data, even though the responses she uses are real responses provided by other participants. The duplication is fraudulent and can create bias in the data. She needs to work diligently to interview everyone on her route. Our last example for chapter 1. For the following, identify the independent variable and the dependent variable. So the Journal of Behavioral Medicine reported that sharing a hug and holding hands can limit the physical effects of stress, such as soaring heart rate and elevated blood pressure. So independent variable here, or explanatory is what we call it in statistics, would be the hug or the hand holding. So either they did hug and hand hold or they didn't, right? And then the response variable would be the heart rate and blood pressure. Now notice I didn't write soaring heart rate and I didn't write elevated blood pressure. It's just the heart rate and blood pressure. It's just what are we measuring? I'm not saying it was high or low at this point. I'm just saying, what am I measuring? Okay, that's it. That's critical. Letter B. People who have obsessive compulsive behaviors are likely to be perfectionists. So the explanatory independent variable here would be obsessive compulsive behaviors. And you would want to decide first, what are you going to agree is an obsessive compulsive behavior? And then the response variable that you're going to collect are, you would ask the question, are they perfectionists? And again, you have to define what you mean by a perfectionist, right? Are they, you have to have something to quantify that or to be able to qualify that. So that would be a question. And then C says, a study was conducted to determine if the marital status of an individual had any effect on the cause of death of the individual. So the explanatory variable is marital status. So are they married or not married? And are they saying that being married causes death or maybe not being married causes death? And then the response variable is cause of death. Okay. So we're also going to be thinking about how are we going to measure these? Are they quantitative or qualitative? So the response variable up here in A is a quantitative measure. It's something that can be measured, your heart rate or your blood pressure. In B, the response variable is, are they perfectionists? So that's really just a yes or no question, right? So that is a qualitative variable. We would tally up the number of yeses and then get a percentage. Okay, that's important to think about. And then C is the cause of death. So, and we would have to have some deciding on what cause of death would be related to marital status, but this is going to be a qualitative measurement as well. And reach out if you have any questions.